Now that you've completed Module 6 and review, I'm going to go over some so that you can check your answers. Number 1 says follow the directions. Draw a ray that starts at point L, 1.5, 2. Let's plot that point. And K at 3, 2. We need to label the points K and L. They want us to draw a ray that starts at point K and starts at point L and includes point K. So what is a ray? Well, a ray starts at an endpoint and it continues on in one direction. So our ray should look like this. Part B wants us to give the coordinates of 3 other points on this ray. Well, it looks like the y is the same because the y has a 2 here and a 2 here. So basically, as long as we have a 2 in the y coordinate, we are correct. So any x and a y coordinate of 2, any x and a y coordinate of 2, and any x and a y coordinate of 2 would be on this line, as long as it starts after 1.5. So it has to start after point L because it goes on and on and on and on forever. So this number has to be greater than 1.5, and the y has to be a 2. We have to draw a second ray with the same initial point, which would be point L, and it contains point M with coordinates 2.5, 3.5. So there's our point M and our ray LM. David draws a line segment from point Q to point R. So I'm going to plot point Q and point R now and label them. There are points Q and R. It says he then draws a line perpendicular to the first segment that intersects segment QR and includes point S at 3/4, 1. As you can see, I've made a line segment QR. Okay, line segment starts at one point and ends at another, so this is line segment QR. We now need to draw a perpendicular line and label point S, so here's point S. We need to draw a line that is perpendicular to QR. So we need to think back to some of our previous lessons. Now I'm going to show you with my highlighter here that if I make a right triangle right here, I have a 3x3 triangle. Okay, so if I make a 3x3 triangle right here, this point right here would connect to S to make a line perpendicular to this. So if that line continued right through here, that would make this line S perpendicular to line QR. So your perpendicular line should look like this. This says name another point that lies on the perpendicular line whose x-coordinate is between 1 and 1.5. Let's look at some of our points. So this one is 3/4, 1. This one is 1/2, 3/4. So if we look at these numbers, we can see that the rule is plus 1/2. So if we want to find an x-coordinate between 1 and 1.5, we could go 1, and what's 1/2 more than 1 is 1.5. Or we could go even 1 and 1/8, add a half, which would make 1 and 5/8. So any of those numbers would be on that line. The next problem says complete the table for the rule multiply by 3, then add 3 for the values of x from 0 to 4. Then use the coordinate plane to answer the questions. So 0 times 3 is 0, plus 3 is 3, so the first ordered pair is 0, 3. 1 times 3 is 3, and 3 plus 3 is 6. The next ordered pair is 1, 6. 2 times 3 is 3, and 3 plus 3 is 9. The next ordered pair is 2, 9. 3 times 3 is 9, and 9 plus 3 is 12. The next ordered pair is 3, 12. And 4 times 3 is 12. 12 plus 3 is 15. The last ordered pair is 4, 15. Part A says which line shows the rule in the table? Well, let's look. 0, 3 over 0 up 3 looks like right there. 1, 6 over 1 up 6 right there. 2, 9 over 2 up 9 right there. All 3 points have been on this line, which is line E. Part B asks us to give the coordinates for the intersection of line B and C. So where B and C intersect is right here. which is over 3 up 9. So over 3 up 9, so the coordinates are 3, 9. Draw a line on the graph such that any point on the line has a y-coordinate of 2. Label your line as F. So a line that has a y-coordinates of 2. So this is going to be a horizontal line such as this. So all of these points have a y-coordinate of 2, which makes this line line F. Which coordinate is 2 for any point on line B? Well, if we look at line B, the only place that could have a 2 would be this point right here, which would be 3, 2. Write a rule that tells how to find the y-coordinate when the x-coordinate is given for the points on line D. Let's write down some coordinates for line D. We can see that line D is right here, so what we're going to do is we're going to write down some coordinates such as 5, 7, 7, 9, 9, 11. So now let's look at this and see. We have 5 to 7, that's add 2. 7 plus 2 is 9, 9 plus 11, or plus 2 is 11. So the rule is add 2. Kim and Lacey want to draw a line on the coordinate plane that is parallel to line A. Kim uses the rule multiply by 3, add 2 to generate her y-coordinates. Lacey uses the rule multiply by 2, add 1 to generate her y-coordinates. Which girl's line would be parallel to line A? Without graphing the lines, explain how you know. First, let's figure out the rule for line A. So line A is 2, 4, 3, 6, 4, 8. Oh, it looks like the rule is multiply by 2, because 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. So the rule for line A is multiply by 2. So think about what you know about what can make a line that's parallel to that. So Kim uses the rule multiply by 3, add 2. Is that going to be parallel? Well, no, that doesn't make sense because she has multiply by 3. So line A is multiply by 2, so the rule multiply by 3 will not make anything parallel to it. But Lacey uses the rule multiply by 2, add 1. And we know that whenever we add or subtract after multiplying, our lines will become parallel. So Lacey's line will be parallel to line A. An airplane is descending into an airport. When its altitude is at 5 miles, it is 200 miles from the airport. When its altitude is at 4 miles, it is 150 miles from the airport. At 3 miles, it's 100 miles from the airport. So if the pilot follows the same pattern, what will the plane's altitude be at 50 miles from the airport? Let's write our coordinate pairs. So let's look. We have 205, 154, 103. What will 50 be? Well, it looks like every 50 miles from the airport closer, it looks like the airplane is getting 1 mile altitude lower. So what's 1 less than 3 is 2. So at 50 miles from the airport, the plane will be 2 miles in altitude. For the plane to land at the airport, the altitude will need to be 0, and the distance from the airport will need to be 0. That's right here at the origin. Should the pilot continue this pattern? Well, let's see if we can get to 0, 0. As I continued, I noticed that going down 50 and going down 1, I get to 0, 1. So 0 miles from the airport will be 1 mile in altitude. And that will not safely get them to the airport because they need to be at 0, 0, and they'll actually be at 0, 1. Thanks for watching. I hope you now better understand and have reviewed the entire end of Module 6. Thanks for watching.